Good day. Today I'm talking about natural dyeing. We love to have color in our clothes, and the way we can get color in our clothes is by dyeing the fiber. Up till the mid 1850s, all the colors for our clothing came from nature. They came from plants, minerals, and animals. Today I have got wool in a pot that's got goldenrod. In eastern North Carolina, in the fall of the year, you'll see a tall weed or wildflower that has a little bunch of little yellow flowers in the top, and that's goldenrod. You can pick the upper tops of those flowers and take them, put them in a pot of water, let it simmer, and you will get pale yellow to dark gold. The yarn here on the table is goldenrod. And today in the pot, you can see what color we're getting today, more of a gold than a pale yellow. And if you notice, I've let the fire die down. You don't want a blazing fire under a dye pot. You just want to get the water to what we call a simmer. And if you notice, there's steam rising from the pot, and that means it's at a simmer temperature. It's not rolling bubbles where it'd be boiling. And to get the color to stay on the fibers, we use a mordant. With wool, I can use alum and cream of tartar, white vinegar, and today I'm using citric acid. Citric acid did exist in the mid-1800s. And my dye today is some goldenrod that has been rendered down to a powder. In this bottle, we have some madder root. It's the root of the madder plant. In colonial times, when you think about the British redcoats, the common soldiers' uniform or jacket was dyed with madder root. And next to this, we have some sumac. You want to make sure it's the non-poisonous sumac. And with sumac, we can get grays to black. And in this bottle, we actually have some cochineal beetles. Cochineal was used in South America early on when Spanish came in and colonized the area. They exported it to Europe. Up to the mid-1970s, most of our red food coloring was cochineal beetles. It's still used today, and if you look, you'll look for the ingredient carmine acid. And next to that, another source of yellow or gold is Osage orange. We can actually use the wood chips of the wood itself, simmer them, and extract the dye from it. And if you've never seen cochineal beetles before, these are the little dried shells of the cochineal beetles. And it's only the females that have the pretty red color. And they're still harvested and used today. It's very expensive. The last time I checked, in modern times, a pound of cochineal beetles cost $80. When we're talking about the cochineal beetle, these three different yarns here on the end of the bench are all examples of cochineal. You can get from purple to lavender, to burgundy, to pink, to light pink, all with just one dye. The gold here we have is, when I was mentioning goldenrod earlier, it is a gold you can get from pale yellow to dark gold, and that comes from the little flower or the goldenrod. Now we have black walnut. Black walnut, you could take the outer hull of the black walnuts and simmer them and extract the dye. The one that you're looking at was from black walnuts and eastern North Carolina. I have done some from the Piedmont area and it got a reddish brown. So I'm thinking also the mineral content of the ground that a tree grows in also affects the color. And now we come to indigo, and it's a very special process to get indigo. All the other natural dyes, you could use simmering water, a mordant which binds the color to the fiber, and the dye itself. Indigo does not do that. We're going to do a little bit of chemistry here. We got to turn the indigo to indigotin. We got to rob the oxygen molecules. So how we do that, the most ancient way was to use stale urine. Stale urine turns into ammonia and it's oxygen free. Now today we can use a chemical that removes the oxygen. But it's really neat to watch because when the indigo is in the pot, the fibers turn a real bright yellow. And as you lift it back into the air and the oxygen molecules reattach, it goes from yellow to green to blue. Now next, when we talk about natural colors and you look at all around us, the trees, the grass, the leaves, you see green. That's caused by chlorophyll. Chlorophyll, when it's used, it's just going to give you yellow. So there's no way in nature to get a true green unless you overdye. This yarn was first dyed with indigo, and it came out variegated. It's kind of goes from pale light to darker blue, and I decided to overdye it in Osage orange. And when I dyed it with Osage orange, we got this really neat yellow and neon green. Now we have talked about all these natural dyes, and here we have an example of the natural white yarn. In earlier times we didn't have the bleached white yarn. It would have been the natural white of the animals themselves, and that's where it all started from, was the white yarn and dyed in many different colors.